morning to everyone. I'm Andrea SCARPONI. I'm from Italy, especially from Ancona in the Marche region. I'm a PhD student at the first year of the course, and my research topic is based on a characterization of warm mix asphalt with chemical additives. This is the outline of my presentation with a brief introduction, materials and methodologies, parameters and preliminary findings, and in the end, there are some conclusions and future aims. So, first of all, I want to say that my PhD research work is co-funded by Ample Infrastructure, that is a society of the group Autostrade per Italia, the biggest company in Italy that do maintenance and construction of motorway pavement, road and infrastructure. Then in my research I use warm mix asphalt that are very important to the environment thanks to the low temperature of the production, thanks to the use of the chemical additives, and it's useful also to reduce the pollution and the energy consumption. And then the other hand, it's useful because I use in our mixture almost 30% of RAP, so we can reduce our waste. In the end, the objective of my research is about determine the influence of different chemical additives used for the production. And this work follows what my colleague did in his PhD period, and he developed a 5-step laboratory approach to identify the properties of warm mix asphalt chemical additives. Now, in our lab, I compact 5 mixtures to simulate the dense graded warm mix asphalt that we can find in the base layer of a motorway pavement, an Italian motorway pavement. And I mix them with 5 different chemical additives. After cut and core, I used 2 approaches to test the properties of these materials. The first one is the traditional, that is composed by the indirect tensile stiffness modulus and indirect tensile fatigue test. Then, to evaluate the Visco Elastic Continuum Damage, I use the advanced approach called SVCD, that is composed by dynamic modulus and cyclic fatigue. So, until now, I test these 5 mixture and I elaborate the stiffness properties compared using indirect tensile stiffness modulus value in megapascal for each mixtures at 20 degrees. Then, from the advanced approach, I compared the complex modulus and phase angle at several temperatures 4, 20 and 40 and frequencies to evaluate the viscoelastic behavior of the material. By the graphs, we can show that there are correspondence between the indirect tensile stiffness modulus and complex modulus because we can show that there are 2 lower curves in the complex modulus graph, L and M, in according to the lower value of modulus, traditional modulus, in the first graph. And it should be underlined that there is a difference in the in the loading of the test. The traditional one is indirect tensile, and the advanced one is axial load. In the other end, about the phase angle value, there are each mixture are quite similar. Then, to analyze the fatigue behavior, I based the observation on the regression fatigue curve derived from the traditional approach with epsilon say value, that is the value of the deformation at 1 million cycles, and the damage characteristic curve derived from the SBCD approach with DR failure criterion, which quantify the toughness of the material and the properties to absorb the energy. It should be underlined that the traditional results are valid only for the test temperature and frequencies. In the other hand, the advanced results are valid for several temperature and frequencies. Then, in the traditional graphs, we can divide it into two groups. The first one is the more strength mixtures thanks to the higher slope of the regression fatigue curve composed by the T and S additives. And then the second group with lower slope, it means lower properties and resistance to fatigue, given by the additives F, L, and M. I also must say that to evaluate the number of cycles given by the traditional approach, I need to use an empirical equation to obtain the number of cycles failure. In the other hand, to evaluate the, the damage, it should be used an intrinsic properties given by the measure of the pseudo strain instead of the real strain. Then, in conclusion, it will be fine a comparison between VCD results and traditional approach. Then, I will be find a possible link between the results given by the advanced approach and the results obtained in the additives with the five-step approach developed by my colleague. In the end, we will find a correlation between these two results. So there are some future aims like an evaluation of fatigue curve performance after long-term aging. So I will need to compact, code, and test the same specimen between the with the advanced approach and evaluate the fatigue performance and dynamic models. Then, if it's possible, we will construct an experimental motorway file trial to investigate the effect of in situ compaction. So, thank you for your attention.